Okay, like I said in the previous video, this was originally just one giant video and it just got to be too giant, so it's broken up into two parts. So if you haven't seen part one, which is evaluating the amp and its condition and seeing what needed to be done aside from just converting it to the cascaded gain, please check that out first. If you have seen that, welcome back, and let's get started on the actual conversion of the 76 Marshall 2204 50-watt master lead, blah, 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 Mark II. Okay, moving on to the actual changes. The parts that aren't going to be used in the cascaded circuit get removed. This Lemco 500 picofarad, I hate the word picofarad cap is the bright cap across the preamp gain volume pot. And so I've removed the solder, and as you can see, the old leads were wrapped around the posts on the pot. Those leads are really fragile, so I very carefully unwrapped them, and that Lemco, along with all other original parts that get removed, will be returned with the amp. All right, here's a look at the cleaned up and redone output tube sockets. You can see I added the 5.6K Pyre grid stoppers, and I put in new 1K 5-watt vitreous enamel screen grid resistors. The cathode chassis ground connections were redone just like the filter cap grounds were redone, where I took everything apart and cleaned it and put it all back together and got some corrosion out of that, because grounds are literally the bedrock upon everything else is right there. If the grounds suck, everything sucks. You can spin your wheels all you want. This is the stuff that has to happen. It's not sexy. It doesn't make for good videos. Blah, blah, blah. It's really just literally the nuts and bolts of things. But I make sure that's done for all the output cathodes and for all the filter caps, and as you'll see later, for all the pots. Okay, going on to the impedance selector switch and the output jacks. Just like the standby mistake that Marshalls have, a lot of Marshalls will have the negative feedback wire connected to the wrong point instead of connecting it to a single output tap on the secondary of the transformer, be it 4 ohm or 8 ohm or 16 ohm. They'll connect it to the center wire on the switch, which feeds the output jack itself, which means that if you have it set to 16 ohms, you have the 16 ohm tap connected to negative feedback. You set it to 4 ohms, you have the 4 ohm tap connected to negative feedback, and so the amp's behavior changes wildly depending on what tap it's connected to. Each Marshall circuit has a particular tap that's used with a particular amount of feedback, and you don't want to vary that. So in this case, it is, I think, going to the 4 ohm tap. I'd have to look at it again. The picture's not in front of me as I do this voiceover. But you want to make sure that whichever one it's connected to that tap, not to the common out going to the positive of the jack. I think that might be one of the reasons people think that a 16 ohm tap sounds different than an 8 ohm tap, sounds different than a 4 ohm tap. To a very small degree that can be true, especially with a substandard quality output transformer. But I think there are enough amps out there that have the negative feedback wired wrong that people are hearing very real and dramatic changes when they changed output impedance taps, but it's not for the reasons they think. Well, anyway, this was correct, but I had to make sure. What was not good was the ground wire connections going to the output speaker jacks. Very grainy solder, and one wire, which was actually the output transformer secondary common, was just tack soldered to that joint. And that's one of the higher current points in the amp. And so I redid that properly. The melted insulation was there already. That wasn't me, I promise, I swear. But it's not melted poorly. It's not bad. It's not a terrible thing. If it was bad, I would have redone them or put some shrink wrap over them, some heat shrink insulation. But you've got good mechanical connections before the solder is applied now, so that's very solid. The entire sound of the amp depends on that ground connection from the output transformer secondary common being good, and now it is. Okay, moving on to the board, you can see the replaced rectification and bias diodes. The original rectification diodes were putting a buzz on the B+, just that was always there. Not fun. So those and the bias diode have been changed for 1N4007s with nice neat leads and no stress. And I like to elevate them a little bit off the board just because they can get a little bit warm. The bias caps, crucial. The bias caps have been changed out for Vishays, which are a really high quality cap rated for like 10,000 hours or something. It's just ridiculously good quality cap. And the 47K there in the bias circuit is now a Pyre. But that the Pyre versus the stock generic, that's not important. Those bias caps are. Notice that I left the original filter caps in this amp, but I insisted on the bias caps. You cannot play around with bias caps. If that bias supply fails and you have $400 output tubes, no, you had $400 output tubes. Is a replacement output transformer for a 76 Marshall expensive? You bet, and you'll find out exactly how if you don't change those bias caps. Fortunately, the owner is sane and agreed with me, so those have been changed out. We'll take the chance with the daily filter caps because they'll probably hum before anything bad happens. Those bias caps, change them. We want that rock solid. Now it is. Now, it's not shown because I forgot to take a picture. And it's really hard to take a picture of the underside of the board while you're holding it up with one hand and working with another. But the bottom of the PCB on these amps has relatively thin traces and pads. There's not a lot of copper there. It's really critical that when you replace things like this 47K resistor in the bias, or you replace the caps or the diodes, that you don't damage, tear, or lift from the board the pads and traces. You have to have the right temperature soldering iron. I've got a temperature controlled station. I would not do this with the 20 watt that you get from the hardware store. I would not do this with the 100 watt that you find at Michael's for people doing craft. You have to have the right temperature. You have to work quickly. You have to have flux. You have to have good solder. You have to have the right desoldering stuff. Anyway, I remove the old solder. I very carefully separate the old lead from the board. I straighten it very carefully. I carefully pull the old component out. I get all the old dirt and flux off the old pad. We use an isopropyl alcohol. I put the new component in. I bend its leads just like the original had. I resolder it properly. Once that cools, which doesn't take that long, I go through and I clean off any flux that I might have added to the board while I'm doing that. And while I was doing that, I also found a lot of factory solder joints that weren't great. A couple coupling caps were barely tied to anything, and crucially, the post that has 3 wires connected to it for the screen node was barely holding on. It had broken its solder joint because it was never done well at the factory. So that's resoldered and it's rock solid now. And it's stuff you don't see, but you sure would hear it. Okay, moving on to the phase inverter. The only thing here that was changed is that 10K resistor was replaced with a Pyre, the tail resistor. And then here we see the coupling caps. In the 76 non-cascaded circuit, the coupling cap on the left was originally a 2.2 nanofarad mustard, and the one on the right was a 22 nanofarad, which it still is. But the one on the right was very, very microphonic, and the owner prefers the sound of a 22 to a 2.2. So both those mustards had to go, and the owner wanted Philips mustards that said 22N, not 0.022 microfarad. So after some wheeling and dealing with my amp buddies, I was able to get 2 22Ns from Mitch Colby at Park Amps. Mitch does great work. Check out Park Amps and the Sun Dragon thing he did with Jimmy Page. He is a gentleman and a scholar, and I don't even owe him any money. But he was nice enough to send some 22Ns, and here you have them. So those are all installed, and neither are microphonic or noisy. Wonderful. And then you can see that new orange 500 picofarad bright cap there across the 470K resistor. The original was extremely microphonic, but more worrisome was injecting noise into the next stage. Sometimes old caps just get noisy. So a new class 2 ceramic rated for 1,000 kilovolts. Not 1,000 kilovolts, 1,000 volts, 1 kilovolt, sorry. Anyway, new class 2 ceramic. It'll sound original, and it's not microphonic, and it doesn't leak, so the amp is less noisy. These are good things. Then going to the cathodes, you change the cathodes with V1, going from the non-cascaded to the cascaded. It's pretty simple. You just remove that 330 microfarad and change the 820 ohm to a 10K, and in this case, the 10K is, again, a Pyre. Next, we go to the input jacks. The original Cliff jacks did not have a sleeve normal connection, which you have to have to properly do the cascaded gain. So those original cliffs were removed, and the original Pyre 1 meg resistor was taken off of those and transferred to some new UK-built cliff jacks. And everything was put in place and wired up properly. The correct top coat, pink wire, etc., etc. All the grounds were nicely wrapped before being soldered. You can see it's got the shielded grid wire going from the high gain input to V1A, and then the preamp gain pot has shielded wire going to the grid of V1B. Actually, that's reversed. High gain goes to V1B, and the preamp gain goes to V1A. Sorry, it's a weird layout on these Marshalls. Weird from a conceptual point of view. Anyway, I digress. And you can see the new 470K resistor in parallel with the 470 picofarad cap from the low gain input to the preamp gain pot, and the new 1 nanofarad bright cap on the pot. All those added caps are the 1K volts class 2, which is pretty much exactly the kind of thing that would have been used in 1976. And then here's probably the weirdest, least sexy, least obvious why should I be interested in this photo in this collection. Just some of the new wires mixed up with some of the old wires. And it's really hard to tell which are original and which are new. You're welcome. All right, back to the really important stuff. We have the pots here. We have the volume, the master volume, the tone stack, and the presence, and that bus wire going across them. One change was I cut the bus wire between the treble and mids pot, which the reason I kept the treble with the master volume and the preamp gain volume is just because that treble pot had a tooth washer and had the best chassis connection of those three. So each bank of pots joined by a bus wire only has one pot that's really, really strong to the chassis with a tooth washer. That's the presence pot and the treble pot. The other pots have those long bushings with nuts on either side. And while that holds, it doesn't hold to the point where I'd really trust that for the primary ground connection, even in parallel with others. What this does, though, by cutting the bus wire, is instead of having all the stuff just kind of going to the chassis in a big wide area, you have the preamp stuff going to the chassis at one point, and then you have the phase inverter and screen nodes going to the chassis at another point, which can break ground eddy currents. One of the things I did to help that along was I removed that wire from the master volume ground going to its bus wire and put in a physical wire from the master volume ground going to the ground lug on the mids pot, which means that the tone stack is grounded, and then the tone stack goes to the master volume, which is grounded the same point that the tone stack is, and then that all goes to the phase inverter, and so it's all grounded to the same cathode, and it's in the same negative feedback loop as the screens, and everything's happy, and you don't have currents flowing back and forth in odd ways, and it just lowers noise. It gives you increased note separation. It does all kinds of wonderful things at almost no expense. So, weird stuff. What you can't see is on the presence and treble pot, it had black oxide tooth washers originally, and those I have found do not give the best contact over time. I talked earlier about metal to metal contact and chemical reactions. Those metal oxides just suck. So those are gone. New tin-plated tooth washers are there, and I removed all the pots and really thoroughly cleaned the chassis and the pots and the nuts and everything where metal to metal contact happens there, because it's very crucial grounds. And before I did that, the amp had some oscillation, and getting all those grounds cleaned and retightened and just really secure went a long way towards getting rid of the oscillation. The other part of the oscillation is shown in the next photo. Boy, this is really long, isn't it? Well, we're almost done. Next up are the preamp sockets. Remember I said there was some oscillation in this amp after the initial cascaded gain changes were done. Well, the oscillation was halfway cured just by cleaning the pot connections to the chassis, and the rest of it was by shortening the preamp wires, making sure that wires going to one triode were not near the wires going to another triode, and very critically making sure that the grid wires were nowhere close to the heater wires. And you can see that even running the V2A grid wire beneath the 100K plate resistor there. And on V1, you can see that both wires are shielded and run as far from the heater, the black heater wire as possible. And all the leads have been shortened, and the lead dress is tightened up. On V1, V1B, which is the feed from the high gain input jack, that has a 68K PIO right there at the pin. And V1B also gets a 100 picofarad cap from plate to cathode, which just blocks radio frequencies and high frequency oscillation, keeps the stage stable, but it's high enough that it doesn't really affect the frequencies we want. And because it's from plate to cathode rather than grid to cathode, it's not in parallel and adding to the Miller capacitance of the tube. So when you roll your guitar volumes back, it doesn't get dark, which is nice, because you should be able to roll back the volume and clean up to some degree. And how clean that is depends on the amp and the guitar, but you want to keep it as natural as possible. So once you start putting a whole bunch of caps from grid to cathode, that's pretty much the guitar's on or it's off. The in-between stuff sucks. All right, and moving to the last picture in this video of the output tubes. A very nice matched pair of new old stock Siemens. Insert joke here, Siemens. Maybe it sounds less 12-year-old in German. But they're new old stock. They're really well matched. They're quiet. They sound great. But the closer one in this photo had a broken off keyway, the locator pin in the center. So I super glued a keyway adapter to it, which both means that the tube is less likely to be put back in incorrectly. And it also gives it some additional stability in the socket, having that center post being held by the socket itself. Not shown, but all the tube sockets were both cleaned and all the preamp tube socket connections were tightened, and that's really critical. I'm not showing the preamp tubes because the old tubes it came with were pretty much unusable. I've tested it with a combination of current production Mullards and Tungstals and JJs, and the amp sounds great. The owner's got a large stash of good new old stock 12EX7s. He can roll to his heart's content and find the ones he likes the sound of best. I know that if the amp sounds very, very good with current production preamp tubes, it can only sound better if you get some Gentle X or Mullards or Emperor X in there, Brimars, whatever he wants to do. But I did want his actual output tubes so I can make sure the amp is biased correctly. And so that pretty much wraps up this video, part 1. Part 2, the actual playing video, will be done very soon. Normally, I will call one of the local Memphis hotshot guitarists to do videos for amps this nice, but with the plague limiting my options these days, I will have to do the video myself. I'm a more than adequate guitarist, and I'll try to do the amp justice, but it's not quite the same as when you get a truly great player. So when you hear that video, have mercy on me. Thanks.